And in this video we're going to be talking about covalent bonding. So what is a covalent bond? Well, a covalent bond is when two atoms share a pair of electrons in order to form a molecule. This involves each of the atoms donating one electron to that shared pair. And this is the type of bonding that occurs in non-metal atoms. So how does this bonding work? Well, all bonding is electrostatic attraction. So what does this mean? That means there's going to be a positive charge and a negative charge, and they're attracted to each other. So in this case, the nuclei of each of the atoms involved are the positives, and the shared pair of electrons are the negatives. And if we look at the simplest molecule you can have, which is hydrogen gas, if we look here, hydrogen is atomic number 1. It's got one electron in its outer shell. And if we've got two of them, okay, and they join together, they can both share one electron each, okay, and that now gives them a full outer shell. Remember, the first shell can only hold 2 electrons, so this is a full outer shell now. Now this electrostatic attraction is going to be between the negative shared pair of electrons and the positive nuclei of each of the hydrogen atoms. So, for the GCSE specification, there's certain molecules you need to know how to draw the dot and cross diagram for to illustrate covalent bonding. And I'm going to talk you through some of them. The first one is chlorine. Now chlorine is atomic number 17, so it's got 17 electrons. Now for the purposes of simplifying this diagram, I've missed out the middle shell of electrons. The real configuration of chlorine is 287. Okay, here I've just got 27 to make it easier. So if we look, each of the chlorines have got 7 electrons in its outer shell. 1, 2, 3, 4, 5, 6, and the dot there is 7. And if we do the same with the crosses, there's 7 there. Just like the hydrogen, if they share 1 electron each, okay, that would then make both outer shells full, because if we look at this one, 1, 2, 3, 4, 5, 6, 7, 8, and then exactly the same with the other one, 1, 2, 3, 4, 5, 6, 7, 8, okay? So that's what makes a chlorine molecule. If we look at oxygen, it's slightly different, okay? Oxygen's in group 6, so its electronic configuration is 2, 6. So it's got 6 electrons in its outer shell. Now when you're drawing dot and cross diagrams, if an atom is 2 electrons short of a full outer shell, that means it's going to want to form 2 covalent bonds, okay? So if we look at oxygen molecule, if we look at one here, it's got 6 electrons in its outer shell, 1, 2, 3, 4, 5, 6, and the same on the other one. Now if these share 2 electrons each, okay, so 2 covalent bonds would be formed. That would be 2 sets of pairs. If we count up now, 1, 2, 3, 4, 5, 6, 7, 8, and if we go the other way, it's exactly the same. So both atoms now are happy because they've got a full outer shell by sharing 2 electrons. If we look at nitrogen, nitrogen's in group 5, its electronic configuration is 2, 3. If we look, it's 2, 5, sorry. If we look, it's got 5 electrons in its outer shell, okay? So this means it's now 3 electrons short to have a full outer shell. So nitrogen is capable of forming 3 covalent bonds. So that means it's going to have 3 shared pair of electrons, 1 pair for each covalent bond. You also need to know about hydrogen chloride, okay? And we've seen these 2 atoms before. Now, for simplification purposes, I've omitted the inner electrons of chlorine. I've just drawn the 7 electrons in the outer shell. If we look at chlorine, it's 1 electron short. Hydrogen is also 1 electron short. So if these share a pair of electrons, okay, they're now both got full outer shells. The first shell, can remember, only hold 2, so it's got 2 electrons in, and the outer shell of the chlorine now has 8. Similarly, if we look at oxygen, water, okay, when drawing molecules where there are more than 2 atoms in, it's always easier to draw the central atom first, okay? So in this case, the central atom is oxygen. So if we draw that one first, and again, we've missed out the inner electrons to make it simple. If we draw in just the outer electrons, oxygen's in group 6, we've got 1, 2, 3, 4, 5, 6. Oxygen will want 8 electrons in its outer shell, so oxygen's going to form 2 covalent bonds. Now when drawing this, because you know it's going to want to form 2 covalent bonds, it's always a good idea to have 2 unpaired electrons when you're putting in your crosses, okay? And that will make it easier for drawing your diagram. Then all you have to do is add in your hydrogens. As we said before, hydrogen's atomic number 1, so just has the 1 electron, which is represented by the dot in these diagrams. And if we look, all the atoms now have full outer shells. Each of the hydrogens have 2, and if we look at the oxygen, it's got 1, 2, 3, 4, 5, 6, 7, 8. And it's similar story with nitrogen, okay, when we're doing ammonia. Ammonia is the formula NH3, so nitrogen's going to be the central atom. It's in group 5, and again, I've omitted the inner shells to make the diagram simpler. So, if we draw the 5 electrons of nitrogen, we know nitrogen wants to have 8, okay, so there's 3 bonds it's going to make. So it's a good idea to draw 3 of the electrons as unpaired, okay? So they've got 1 cross there, 1 cross there, 1 there, and a pair of electrons at the top. That'll again make it easier for when you add your hydrogen atoms on, okay? Remember, hydrogen's just atomic number 1. And again, each of the atoms there now has a full outer shell due to sharing its electrons. And similarly for methane, okay? Methane CH4, the carbon is obviously the central atom. So again, I've omitted the inner electrons to make it simpler. Carbon's in group 4, so here's its 4 electrons, 1, 2, 3, 4. We've put them all as not in pairs, again, to make it easier to add on your hydrogen atoms, and now you have 8 in the outer shell of carbon, and each of the hydrogens have 2. Carbon dioxide, this is the last one we're going to be looking at, okay? These are all the molecules you're required to know for the specification. Carbon is going to be the central atom, okay? So we draw in the 4 electrons of carbon, which is represented by the stars. But this time, remember, carbon wants to make 4 covalent bonds because it's 4 electrons short. So each one of these bonds is going to be a double bond. And it's a double bond because there's 2 shared pair of electrons. 1 shared pair is 1 bond, 2 shared pairs is a double bond. And if you look, all the atoms again have 8. So, to summarise, okay? Covalent bonds involve sharing of electrons. Electrons are always going to be shared. Like all bonding, it's an electrostatic attraction. The electrostatic attractions between the 2 positive nuclei and the negative shared pair of electrons. This type of bonding occurs in non-metal elements, and the number of electrons required for a full outer shell is the number of covalent bonds an atom will want to make. So carbon has 4 electrons in its outer shell. It would like to have 8, so that means it's going to make 4 covalent bonds to get 8 electrons. And lastly, when drawing your dot and cross diagrams of a molecule which isn't diatomic, which just means 2 atoms, so it's got more than 2 atoms, always draw the central atom first, and that will make it easier to draw the diagram. Hope you found this video useful. Thank you.